Hello, this is Dr. Hassan Abdullah with the course Web Applications Programming. And the topic which we are covering is Web Applications Architecture. This is topic number 5. So, what is Web Application Architecture? It is the way in which different parts of a web application are identified and how they are connected and how they work together and what are the different types of architecture and what are the benefits of them and which architecture which we will be using and why we will be using it and what is the purpose of that architecture, what is the benefit of that architecture, and so on. So that is what is going to be covered in this video lecture. And as before, this video lecture is used and it is using is based upon the supplemental website easymcq.com/GoGet, which is a personalized learning management system. Now this is an automatic system. This is an online system. This is just not. It's not like a traditional ancient slide-based approach, which is static, which is passive, which is non-hierarchical, which is outdated basically. So this is you have many courses available here which have full text sets, advanced and basic. And if there is a visual disability, you can set the font color, shape, size, background, and so on. And it is optimized for a mobile phone. There are online exams there, you can track your progress also. So these are wonderful features, and these features are explained in 6 videos, and these videos are available on the URL in front of you, or you can go to YouTube and type my name, Dr. Hassan Abdullah. It will take you to my YouTube official channel, and the videos are there. The videos are also available on the Canvas also. So I would strongly urge you to look at those videos. That is a wonderful feature of this approach which I have adopted in this course is the question and answer based approach. Instead of the traditional approach in which there is a topic and there is a description of that topic and it never changes. So this is a question answer based approach. This is a proactive approach. This is an engaging approach, and it sharpens your thought process, and it makes you adaptable, and it is based upon real life scenarios. So the list goes on. So this is going to be a very challenging, and it is going to be very interesting and a wonderful and a great learning experience for you using the question and answer based approach. So the topics which we'll be covering in this course are listed before you, and the topic of our interest for this particular is the web application architecture, which is topic number 5. Now this topic consists of a number of concepts, and those concepts are written and described in the form of questions and answers, and which are listed before you. And every concept has bullets, and every concept have a background, every concept have a summary, and every bullet has a description, and then there are references for further reading, and if there is a need there are diagrams also. So this is a very powerful and useful feature, and this is just to give you an idea of what to expect so that you're ready to see what you're going to come across. And then we move on to the supplemental website, and we will click on each of these questions and we look at all the details, and that will be a wonderful and learning experience for you. So we are at the supplemental website, or the web application to be more precise. And as I mentioned earlier, that this web application has wonderful features. And to know about those features, there are 6 videos here. And the first video talks about why the question and answer based approach has been adopted in developing the course material. And then, of course, how the content coverage is done and how the navigation takes place and how the space is optimized and so on. So I would strongly urge you to view those videos to get the most out of this web application for easy learning. So let's move on to the course of our interest which we are covering, which is web applications programming. So we go there and we move on to the topic which we will cover in this video. So that topic is web application architecture. So I click on it. So what are web application architectures? So the web application architecture means that how the application, okay, let me write it for you on the screen, that how the application is designed, okay, is designed and is operational, okay, and it is deployed, okay. Of course, there can be similar meanings also, Okay, so this is what is a web application architecture. So there are different types of architectures. uh, I will not go into lots of details in all of them because the type of architecture which is of our more interest, okay, that is the three-tier web architecture. Because throughout this course we will be following the three-tier architecture and I'll talk more about it. But of course, I will briefly cover the other architectures also. So first is the monolithic architecture. So the monolithic architecture means that everything is contained in one machine. It's kind of a standalone machine and it doesn't have any network access. And of course, it has its own application domains. So I'll go into more detail. So that is the monolithic architecture. Then is the microservices architecture. So basically, what is required to run an application that is divided into different kind of a disjoint services, and those services are scalable and collectively they get the job done. So that is the microservices architecture. Then is the serverless architecture. So this is basically in the context of cloud, say for example Amazon Web Services or Azure. So the coder is not concerned or not worried about the underlying architecture. They are more concerned about coding the application. So as per the requirement, which could be in terms of load handling, okay, the underlying architecture is made scalable, and whatever is the amount of scalability employed, so the end user is charged for that increase in the scalability. Very briefly, there is a three-tier architecture. So the three-tier architecture basically it divides your application into three disjoint parts, so to say, and of course those parts can communicate with each other, and they do communicate. So we have the client tier, which is the first tier, then we have the application tier, which is the second tier, and we have the third tier, which is the database tier. So of course the client communicates with the database tier through the application tier, and the database tier communicates with the client through the application tier, the second tier. And then is the event driven architecture. I'll talk about it. So how they are developed, organized, and deployed. So organized is the better word. So, this basically, of course, the choice of the architecture affects what? It has profound effect on the scalability. Scalability means that as, say, for example, the load on the server increases in terms of more traffic or in terms of certain types of queries. Okay, so the scalability means that the architecture underlying can be can be changed, so to say. I'll talk about it so as to cater for the load. Maintainability is that you are able to make changes in it, upgrade it, update it, and so on. And the performance of the web applications, because performance, of course, is important. There are a number of ways of providing the performance, and and the last Q&A in this topic is about performance. So so these are some of those architectures which I have just mentioned. Okay. So let's move on and briefly discuss those architectures one by one. So monolithic architecture is the traditional approach, okay? So this is deployed on a single unit, okay? And of course, its advantage is that it's very simple and ease of development, right? And it works for small to medium sized applications. And of course, it has some issues also, because when the application grows, okay, when you add more features, when you have more traffic, okay, then it becomes challenging. Why? Because everything is integrated together, and if you make change in some part of it, then you need to redeploy the entire application. That can be nightmarish, okay. Why? Because things are tightly coupled. Since things are tightly coupled, therefore this coupling, which is an advantage, but that can become a disadvantage also, because it can lead to bottlenecks. All right. All right. So then is the microservices architecture. I'll probably, maybe I have a diagram at the end. No, I'll show you this. I'll show you this corresponding diagram also. So we have loosely coupled services, right? And they are focused on specific business capability of that specific domain. And of course they run independently, because if they cannot run independently, then you cannot then you cannot kind of break them. Okay, and you cannot run them in parallel. So the advantage is obvious, which is the scalability and flexibility, right? Because they are working independently, so that you can work on them independently, you can deploy them independently, you can scale them independently, and you can update the services and so on. So what is the advantage? The advantage is that there is no bottleneck. Unlike the monolithic, which itself becomes a bottleneck, it has little or no bottleneck, right? So it means that there is less downtime. The performance may degrade to a certain extent, but it reduces the downtime. Okay, of course, but you see that there has to be robust communications, right? Why? Because since these microservices communicating, and some maybe say have a slower communication link for some whatever reason, then the overall performance will suffer. Then is the serverless architecture. So developers focus only on writing the code or individual functions, right? And they are not concerned about the infrastructure which supports those services. And what who are the service providers? As I mentioned before, there's Amazon Web Services and Azure and so on. So they automatically scale the application in response to demand. Okay, and of course charge only for the resources used during that time, right? So for example, for certain reason, maybe the flights are cancelled, right? And maybe it's just a storm or something else. So there's a peak in the cancellation, right? Or there is a peak in the queries or whatever. So this automatically scaling is done. So that is the serverless architecture. Three-tier architecture, I have been mentioning it a lot. As a matter of fact, there is a complete Q&A on three-tier architecture. Event-driven architecture. Okay, this is very interesting, based on production, detection, and reaction to events. Okay, so when certain things happen, okay, then there's a coupling or decoupling of making it easier to introduce new features or change the existing features. Okay, without disrupting the entire system. So it's kind of a living in double core system, event-driven architecture. So this table at the bottom, I just kind of zoom into it. So this shows the monolithic is single tightly integrated application. Okay, in terms of components, and event-driven producers and consumers of events. The multiple three-tier architecture, presentation, business logic, and data layers. Multiple serverless. You don't know, functions executed in the cloud. So you see that there are quite a few variations in these five architectures which we have discussed. And of course, you being a web applications programmer, you should be knowing about these architectures, because the choice of architecture will ultimately dictate the type of performance, the type of service, the type of response, the type of security, and the list goes on. Okay, so of course, it's not possible to cover all of these architectures in this course, maybe in some advanced course, but not in this one. So in for this course, it is sufficient to know that the three-tier architecture is the best one in terms of scalability, in terms of features. So let's look at the one-tier architecture. So it's a single layer architecture. Everything is available at one place. Okay, so the user interface and the logic is combined together, right? And it runs on a standalone system, right? It's like if you have your personal machine and you have your personal application, web application running on it. Maybe you are developing in that environment, and once you have developed it, once you have tested it, once you are satisfied, then you upload it. Okay, and then of course many surprises. You should be ready for many surprises, because things work perfectly on your machine. Everything is in your control. So, but when they are uploaded, then there are many surprises. But that's the way the life is. So runs on a standalone system, minimal network dependency. Okay, so you have minimal network dependency, but when you upload your web application or part of it, then it is fully dependent on the network, and then comes the real test of its performance, its response time, its load time, and so on. So it has limited scalability and flexibility, right? When of course you are developing it on your stand. So these are the explanation of these points, which or the bullets which I mentioned. So we have the one tier architecture, we have the presentation layer, we have the application layer, we have the database layer, all at one place combined together, and this is the client tier. So there is no server tier, this is just the client tier, that's it, everything is bundled together. So then we move on to something which is called as the client server architecture, which has been around for quite a while. Okay, I believe this predates the web also, because airline booking systems or similar systems have been around for a very long time. So you have a client and you have a server, and the server has the processing power, and the server has the database, and the server has the business logic also. So basically, what the client is the user. So that user, if that user has maybe a terminal at ancient times mean like 30 years ago or 40 years ago. So in the domain of technology, that is ancient time. So there's a client with a user which doesn't have any smart machine, which is a dumb terminal, okay? And then the user makes a request to that server, and that request could be for data, that request could be for service, and that server which is just a server, it could be called a web server for the sake of understanding. And that server then looks at that request and processes that request for the data or service, and then it responds to that request, okay, and delivers what was asked from the server, and the client receives the response. So that this is a so this is just like what I mentioned was the airline booking systems, because it was very expensive, and there was a central server somewhere located, and then and of course the clients were booking agents working in their offices, and their customers sitting in front of them, and they are using this client server environment. And of course this can be mapped to the domain of web also. And this architecture is used in many modern systems, from simple web browsing to more complex applications like online banking. So online banking, social media platforms. Why I'm mentioning online banking? Because this appears to be more secure, right? Now it's like a double-edged sword, as a matter of fact, because if you break down into application layer and into the database, the tier. So I'm sorry, not the layer, but the tier. So maybe that's more secure. But if everything is bundled together and it's a secure place, then maybe it's more secure. So it's a matter of perspective and the application domain also. So the basic client server model separates tasks between client devices and the centralized servers. Okay, so makes it ideal for high demand systems. High demand systems, because at the example which I gave you of that airline reservation system, so that is a central reservation system that is not specific to a certain airline. So there is a centralized reservation system, and many airlines are their customers, and those airlines then have their customers in the form of visitors or the people who are making the reservations and so on. So the client is often lightweight, as I gave the example of a dumb terminal, okay, and the server handles all the heavy processing. Now this type of environment can be mapped for a web environment, but we don't have that kind of heavy processing load, okay. Uh, Unless of course we have certain specific types of applications. So we have the client, we have the request for data service, which could be asking for a web page or query for specific data in a database and so on. And of course, then the web server is a central component in the context of web application development. Then there is a request, and that request can be fetching a static page or dynamic content also, like querying a database for user specific data. Now, why this dynamism is different from what we have in a three-tier architecture, because what is dynamic here is that the result which you are getting, Okay, that result changes as per the database, as per the query presented. Okay, so display all those students with GPA greater than 3, display all those students whose GPA is between 3 and say I don't know 3.5, and whose major is food technology. So the display is changing, right? So it's not constant. But what we call dynamic in the context of web application programming is that based upon that result, all right, that result, the display gets different color. It can get different font. It can display in a certain way, or it may not display in a certain way, and so on, right? So that's what is pure dynamic content. So basically, that what dynamic content we talk of in 3-tier architecture is basically the HTML, which is dynamically generated by the middle tier. Okay, dynamic HTML, right? That's what I was referring to. So this is how it looks like. So you have these clients. So this is a desktop machine, it's a laptop. It could be a smartphone. It could be a tablet, and they are connected over the internet to that server. So it gives the type that, so this architecture is valid. Okay, the client server is valid, but remember that the client server architecture is not a two-tier architecture. It is not a two-tier architecture. So what is a two-tier architecture? You have the client tier and the server tier like before. So you have the client tier and the server tier, which is the web server. Okay, but the mechanism of communication is different also. The other thing is that the direct client database communication, which is not there in the client server. So in two-tier architecture, the client may be allowed to directly communicate with the database server, and it is simple to deploy, but it has limited scalability because the nature of the server is very different. So without going into lots of details, let me show you the difference between these two types of architectures. So the client server architecture definition: a computing model where client and server communicate over a network. Okay, fine. A specific implementation of client. So this two-tier is a type of implementation of client server architecture with two distinct layers, client and the database server. So you see the difference here. And then of course the number of layers can be 2-tier, 3-tier, n-tier, but 2-tier means 2-tier. It is fixed at two layers. For logic distribution, business logic can be on client server or middle tier. Business logic typically resides on the client side, and the second side, or it is the database layer. Okay, so more flexible and scalable with added tiers, less scalable compared to 3-tier, or because that's the way it is developed, that's the way it is been designed. All right. So performance can be optimized using middle tiers, may suffer if business logic overloads the client. Right. So usually the clients are my client is your laptop or your smartphone or your PC. Now in case of PC, of course, that it has more processing power and it has more memory also, which is not the case typical for a typical smartphone. So it may suffer. Okay, the performance may suffer because the business logic overloads the client. Right? There's a big difference here. The server in a client server architecture is very powerful. All right. So let's move on to the 3-tier architecture. So the 3-tier architecture, separation of concerns. So the client is separate. All right. The business logic is separate, and the database is separate. So what is the benefit? The benefit is the scalability. So you can scale up the client as per your requirement without affecting the middle tier, or you can scale up, or you can perform maintenance on the middle tier, right? And you don't have to perform maintenance at the client tier, right? Of course, what you make changes in the middle tier will ultimately will be reflected on the client. But you can do this, right? You can do this without uh, doing something on the client at the same time. All right. Say for example, I would like to change the. This is very simple example. I am displaying the results of retrieving data from a database, and I would like to change the column names, and the data is displayed in a table. So what I do is that I change the column names in the at the middle tier, That's what I do. That's it. I change it. And if I'm more innovative, what I can do is that I can make the CSS also dynamic. So what I can do is that depending upon the changes, now I'm getting more innovative. So depending upon what results I get from the database, right? I change the contents of the style sheet in the middle tier, and of course the appearance changes at the client end. So I'm doing all of these things without doing things at the client end. I believe you understand. So performance optimization. So let's go into some details. Performance optimization. So it is another key benefit. By separating concerns into different layers, each layer can be optimized independently for better performance. So for example, I can change the schema of the database layer, right, to get better performance, right? uh, of course, that may or may not, right? For there are certain things which I do at the database layer for which I will have to make changes in the middle tier. But there are certain things which I can do at the database layer for which I'm not required to make any changes. I'll give you the example. For example, if the performance was not good, so what I will do is that I will the columns which are used in the query, right? I will index them at the database layer. So what will be the outcome? The outcome will be that I will have the queries running faster. Now there are other things which I can also do, which is not part of this course, but for the sake of your interest. So if I have this schema with multiple tables, so for the tables for which I have multiple times I am doing a join operation, which we will cover shortly. So I may denormalize, I may combine those tables together. So what will happen that instead of running a join command in SQL within so I don't have to run a join command. So for that purpose, there is no change. So that purpose, there is a change in the database layer, and there's change also in the middle tier because I have changed the SQL also, because there are no more two tables. There's no join. There's no equi join there. I believe you understand. So my apologies if I have gone too advanced, but these things happen. So let's look at it. So we have this client server architecture, right? So we have different clients, and we have this LAN, and we have this server. So this client server architecture is very similar to a two-tier architecture, but you can see that this communication is over the internet. Okay, so this is not over a network. It's a big difference, right? Usually this is first tier, which is the client. Second tier, we have this application server, and we have the database. And the three-tier architecture, you can see it. First tier is your client, which can be your smartphone also, and the second tier is the server, and the third tier is the database, right? So I believe you understand. All right, so let's move on to the last Q&A. What are the strategies for improving scalability of a web application, right? So I wish that, and of course, if you'll be able to develop applications and host them and market them, and of course they may be attracting a lot of traffic. So when these applications are attracting a lot of traffic, number one, so the server gets loaded, and number two is that the type of queries, okay, which you are experiencing, and maybe those queries are in the right type of query, right, as in WRITE, not RAGHT. So they are right queries. So what will happen is that those queries are going to first lock certain rows, and then lock the blocks, and they end up locking the tables or the database, and the performance degrades. This is not part of this course. This is part of the database course, which is hosted on easymcq.com. So you can go to the main page in the, or you can click on databases or go to the main page, or in the yellow box to type performance or something and databases also, and you will get to the explanations. So we have this horizontal scaling. So what happens in horizontal scaling is that to cater to the load, you add more hardware. Okay, hardware as in more servers, because adding hardware is also in the form of CPUs and memory also, right? Because remember, your application is running in the memory, in the RAM of your machine. So if you want to get a speed up, you can add memory. So both these horizontal scaling and vertical scaling, they involve hardware, but horizontal scaling is you add more servers to handle the increasing load. Okay, so you assuming that your queries and your application is written in such a way that it can be parallelized. So parallelized, for the requirement for parallelization is that your queries can be run or should be run independent of each other. For example, you are querying from say different cities, so the data for different cities is usually disjoint. So those queries can be run in parallel, and when the results are made available, then you combine those results to get the overall query. So that can be you can get a speed up by adding more servers. Okay, and vertical scaling is by you add more you add more, say for example, RAM, or you add more CPUs. So over here, so the differences what we have is CPU, memory, or storage as in hard disk, but that is not going to have a significant impact. Okay, and the other, and over here you have adding more servers for horizontal scaling, and you have adding CPU or memory. Okay, so that's vertical scaling. Then is the caching mechanism. So cache memory is fast memory, number one. So cache memory is very fast and it is on the CPU usually. So RAM is very fast. RAM is on the motherboard. Okay, and hard disk is external to the server. External means that it's not on the motherboard. So usually hard disk access is like several hundred thousand times slower as compared to RAM access. So, but cache memory is faster than RAM because it's on the CPU, so it doesn't have to go through the motherboard. So, cache mechanism means that data or images or certain pages which are frequently accessed, okay, and they are static. So those items or those elements are kept in the cache, okay, and when they are called, or when any item is called or image is called, first the cache is checked, and if those items are there, then they are retrieved from the cache, like images or style sheets. Okay, now I've already mentioned to you that there is a downside to it. The downside is that when you are developing certain web applications and you change the images, which normally happens a lot. Maybe the sizing is not proper, maybe the aspect ratio is not proper, maybe something else, maybe the whatever. So, and you change the image, right? You upload the image, you override the previous image on the on your on at your hosting end. You delete the image, you put a new image, right? Right, as in RIGHT, right? And still your page is not showing the changed image. The reason being, the image is being fetched from the cache, right? So what you need to do is you need to delete the history for the last 1 hour. Don't delete it for like a week or so. Delete the history for 1 hour, so that cache, you need to empty the cache basically, and then the changes which you have made will become visible. Otherwise it's very frustrating. Okay, so this is a note of caution. So database optimization, there are many techniques for optimizing databases which are not part of this course. And for example, you can do this by indexing, right? You can do indexing, okay, and you can ensuring efficient data models. For example, denormalization, which is not part of this course, okay, and tuning the database server itself, right? So there are many things to be done, which are not your domain as web application programmer. This is the domain of the DBA, database administrator. So if your hosting service provider allows you to make a request to the DBA, then they can do it, right?
And of course, then you can, what you can do is change the schema, how tables are connected, how the indexing is done, and other stuff which you can do. So, and that's it for. And then is the microservices architecture. I promised I'll show it to you. So this is the microservices architecture. So different microservices, right? And then there's the API gateway. So and of course they are separate. These databases could be physical. These could be logical also. If they are physical, it's going to cost more, but it's going to give you better performance. And if they are logical, it's going to cost less, but it will not give you the type of performance you are looking for. All right. So other mechanism of getting performance, I'm skipping this CDN, asynchronous processing, sending an email notification after user submits a form. Okay, not immediately, right? Or processing large file upload. Okay, and that is done asynchronously. Because if you're doing everything in real time, which may be required for certain applications, of course that degrades the performance. But if you kind of put them in a queue and they're ultimately done, then of course that gets a better performance. Database sharding. So what you do is you break database into smaller, more manageable pieces, okay, and distribute across multiple servers, right? Of course, you can do this depending upon the nature of the query and the type of the database. For example, I gave you the example of a multi-campus university. Okay, so maybe the university has 5 campuses, and there is hardly there may be certain students who are registered at one campus but taking a course at another campus, but they are exceptions. But usually that's not the case, right? So you spread the data across those 5 databases, okay, so, by splitting your main table. So that's physically done. Of course, you keep the master table at some place also. This is again a case of denormalization. And so what happens is that you are into smaller pieces, and allowing parallel processing of queries, right? And then you combine them, right? So this is divide and conquer, but ensure data consistency. All right. So you have to be careful about all what you do, because remember, your boss may can forgive you. Remember, mark my words, your boss can forgive you for slow response time, but your boss is unlikely to forgive you for inconsistent data. All right. So with this, we complete this topic. Thank you.